Good morning, everybody. So, uh, yesterday we solved a problem, and that problem, as you know, it had three uh, elements only, but still we had to do a lot of work actually. So in assembling a Stiffness matrix, for example, and now if you imagine if you have a big uh, problem, meaning that if you have more members, then it becomes even more difficult. So what we can do and what we do basically, and this is also the purpose of any finite element course, to introduce you to programming as well. So, and that way whatever you have learned can be applied. So we have been using last year we used Scilab, which is actually replica of MATLAB. So, however, I have updated my laptop, and previous version of Scilab is somehow it's not working. So I will go back to the MATLAB now. So today we will do some MATLAB programming, and we will try to uh, see how to implement basically. So the problem we solved yesterday, if you want to solve using computers, how will you do it? So this is what we are going to do. Okay, so I'm going to share the screen, the MATLAB screen. Yeah, so is it visible to you all?
Yes, sir.
Yeah, okay, nice. Yeah, so our problem, if you remember, we had a trust problem, we had three members, and same thing we are going to solve. And we will have a new uh, file. Yeah, so a script file, and this we are going to use. So let me um, increase the font size. Again, I tell you that I'm using MATLAB after very long time, so like I just use only once in a while, and I was using Scilab. MATLAB I used long back, but still these are easy ones. So if I have to increase the font size and all, probably, I don't know, maybe, yeah, we will just yeah, so we can use like this. So okay, so how do you start? Well, first of all, you are going to uh, so let's write here this. We are solving the problem number 2.4. Yeah, so percentage sign is actually the, we have MATLAB, it's fine. We say problem, we will solve, save it as problem 24 2.4. Okay, save. Okay, yeah. So when you say percentage means you are actually commenting it. Yeah, it's like double slash in C++ you use. Yeah, this is similar to that actually, so I think double slash you do it. Okay, now the first thing you will do is you know that what kind of problem you are solving. You are solving There's a triangle shape. I mean, there are three elements. So one element has 135-degree orientation. The second one is 90-degree orientation, and third is 45-degree orientation. Okay, so this is the same problem as we solved yesterday. So first of all, we have to uh, define the what you call it, the xy. Yeah? So xy is my variable. Yeah, and we are going to give the x and y coordinates, all the nodes. So the first node, if you remember, was -1, -1, 1, right? This -1, 1 was the first one, node number 1. Node number 2 was 0, 1. Node number 3 was 1, 1. And node number 4 was 0, 0. Yeah. Okay. So this is, you can also write, these are the uh, nodal coordinates. So we write here nodal coordinates simply. Yeah. Okay. Okay. Now next, we also have to uh, define the connectivity, how they are connected, and that is important. You can say this is IJ matrix, where how we are going to do it. We are going to connect it. Connect, and how? What is the connection? If you remember the yesterday's problem, node number 1 and 4 are connected, right? So element number 1 has which two nodes connected? Element number has node number 1 and 4 connected. Okay. Then element number 2 has node 2 and 4 connected, and element number 3 has node 3 and node number 4 connected. Yeah, so this gives us idea about the geometry of the problem. Yeah. So, and you can find out number of nodes n. So first let's comment it here. And what is this? This one is what we call it, nodal connectivity. Nodal connectivity. Yeah, matrix. You can say matrix. Okay. Okay. Now next is based on this, actually you can find out now what is the value of like what is the total number of nodes. So n is equal to total number of nodes, and we can just find out by size. Yeah, size of what? xy. Yeah, because, and then you have to find out the dimension, which one you are talking about. Yeah, so if you look at this guy, this one, you have node number 1. This is for node number 1. This is for node number 2, node number 3, and node number 4. And this is the size of xy is 4 by 2. Yeah. So number of rows is 4. Number of rows is 4 means is we are talking about the dimension 1, meaning that the rows. So number of rows in xy matrix will tell you how many nodes are there. Yeah, so we can find out from number of nodes from here. Number of nodes. Similarly, number of elements you can find out. All those things we will need it later on. So that's why we are doing. So size of ij, and again, if you see in this, you have number of columns 2, number of rows 3. So this is 3 by 2 matrix, and number of nodes, number of elements we can find out by the first number of rows. Based on that you can find out. So this becomes number of elements. Yeah. Okay. So we got some ideas so far. It's all about the geometry only. Now next thing is all other data that you need, right? So you know that a over l, so e value you have to give. Yeah, so e is equal to, is given e to power 11. Yeah, Pascal is given. So this one is Young's plus, which is the data that you have to give. Area is also given. For the three elements, area element is area vector you can define, which will be like this: a equal to a1, a2, a3. So you can give this value is 2 e to the power minus 2 is the first one. Second one is 1 e to the minus 2, and third one is also 2 e to the minus 2. Yeah, so these values are given for the three elements. We have the three different areas. So this is sectional areas, which is also given. So all these data are given to you in the problem, and hence we are writing those things. Okay, e is also since e is a constant for all of them, so we are taking it as like this. Now ea over l, length we have to find out. Yeah. Okay, so either you can write a subroutine to do it. So what do you have? You have xy. So this is node number 1, this is node number 2, this 3 and 4. But ij will tell you that how to connect it. Means 1 and 4 is connected. So this coordinate and this coordinate is connected. Hence the length we can find out. How? This will be 0 minus minus 1 square plus 0 minus 1 square, root of that. Yeah. So you can in fact write a function to do it, or you can just write here a loop. Yeah. So for I equal to 1, yeah, 1 2, total number of elements ne, yeah, and then you can find out like this ij. So ij, node number 1 you can find out node 1 is equal to, so I'm there is not a definite way of programming. You can program your own way, but I'm doing it a long way so that everybody can understand. So what we want to do is, for every element we want to find out which is the first node is, which is the second node is, and then difference of the coordinates. Based on that we can find out what is the uh, like a distance between the two nodes, and that will give us the length of the element, right? So n1 will be equal to, from where we are finding out node number, right? So this ij, n1 will be equal to ij, okay, and then we have ith one. But remember, this gives you j column, or which one we are talking about. Now, elements, this is for element number 1 and 2 and 3, right? So we are interested in both the column values. We want to select the ith row, because ith row means the ith element, right? So we want the ith one only. So we want to choose both the columns of the ith row. So n1, or we can also write a small n as well. So n, ni, let's call it ni. Okay, so this ni has two values. This value will be giving, if I equal to 1, it will give you this. If I equal to 2, this should give you this. I equal to 3, this will give you this. Where ni1 will be the first one. Yeah, so that means what? Our xy1 will be equal to nothing but xy, and then xy because xy ny1, I take it as 1. Yeah, okay. So okay, let's do one thing first. Let's complete this first then. Okay, so our xy, so nij, so in ij we are getting, extracting this one. So for node number 1, sorry, for element number 1, it has node 1 and 4 connected, so we got i4. Now corresponding value we will get from here, means node 1 we have to find out what's the coordinates are. Yeah, and just we have to find out this. We get this one. If we get this one, that means this becomes 1 1 1 2, right? This is 1 1 1 2, because only there are two members. So x1 will be equal to n I 1 1. This gives is node number. This gives us the node number. Okay, so okay, this is the node number that gives you. So I will separate it out so that it is not confusing. Okay, so like this. Okay. So we get ni, which has the two nodes. Now what we are going to do, we separate out nodes. So n1 is equal to ni11. This is node number 1. N2 is equal to, so I'm writing is in a long way, so that you can understand. Otherwise, it's possible to write it very fast or in very shortcut manner. I will share with you some file which is already programmed, so you can run it. Now n1, n2 is ni12. So we got node number 1. This is node number 2. Right now, xy of node number 1 will be equal to xy, yeah, and then node 1, yeah, and then we want to have both x and y coordinates, so we will take both of them. Similarly, xy2 will be equal to, we copy the same thing here, xy, but n2 now, second node, right? So n2, 2, yeah, and get all of them. So so what we get, this is the first coordinate, this is the second coordinates, right? Okay, now dxy, that gives you the difference between the two. So you can write xy2 minus xy1, yeah. And so we get the differences of the two, right? And then finally we have to find out the length, right? So then we can find out L, or just L is equal to, and what do we find out? We find out SQRT, square root. Okay, so there is a better or fancy way of writing that also. You can do dot product and all. Okay, that MATLAB is very good at. But still, what I want to do here is we have dxy. So there are two components of dxy. So dxy 1, 1, 1. Yeah, so I will take a square of that, plus dxy 1, 2, yeah, and square of that also. And then we take the square root of that. That gives you the length L. You can also define length, or you call it LE. Okay, okay, and that will be, you can write it as zeros, and defining how many, this the size we can give. So how many length, there are 3 elements. So number of rows we want is only 1, and number of columns we want equal to number of elements. So that's it. So we can write like that. Yeah, so you can put here L E, and you can write it as 1, and I is the element this is element number that it is keeping with it. So LE is equal to L. Yeah, yeah. Okay, so here what we did, this is the length, this is the length of the elements. Okay, and this is the loop in which it is running, and we have that. Anyway, so far we can also run and see if it's working or not. Yeah, so let's see. What you have to do here is just type here prob 24. Yeah, and already you can see some answer here, tells you which all things are there. TXY you got, LE, and all kind of things in workspace you have seen. So in fact any value if you want. So for example, LE we are typing in the command window, and you get, see here, you get these values 1.414, 1.414. So it's correct. That's what we wanted. Yeah, so you can also, while you program, you can also check whether it's correct or not. So far we got correct. did not get any error also. So that means everything is fine. Okay, so we got this now. We got the length, area, all those things. Now we have a stiffness matrix. So we have to compose. Yeah, and how we do that? Now we know that we can write again for every element. You have to compose the stiffness matrix. Yeah, so how do we do that? So first we will make some universal k. Yeah, so we can write k, this the big k. Yeah, k equal to, let's make it zeros. Zeros means it will make everything zero. What is the size of that? So first we have to find out the total degree of freedom, right? So our have DOF, degree of freedom, is equal to 2 times number of nodes, right? 2 times n. Do we have n? N is here, number of nodes. Every node has 2 degree of freedom, so 2 times n is degree of freedom. So is done. Now k will be zeros of degree of freedom, comma degree of freedom. And so total degree of freedom is 8. So 8 by 8 matrix k max. Okay, so it's all zero zeros. Now for every element we have to do it, right? So for, we can also, j is equal to 1 to number of element. Yeah, and then we have to write here for every element we want whatever you want. Remember, we can also have some angle calculated here, right? For every element, what is the angle that we can find out by calculating the length. So let's say angle also we want to find out, or ang ang is equal to, again we put as zeros, 1 me, and let's call this angle or orientation of all elements. Yeah, so we want to keep it here. Okay, fine. Now length we have found out and we have put like that. What will be the angle? So angle is equal to, how do you find out? If you know the coordinate of the two, you can find out angle with respect to so let's say you have x1 and x2, then y1 and y2. So y2 minus y1 over x1 x2 minus x1, that gives you the tangent basically. Yeah, but from there, can you find out? So we have the dx, so we have d this one, right? Yeah, so dx2, so we have the dx2, dxy, and this will have 1 2, right? So this has the del y component, right, divided by dxy 1 1. Yeah, so this is the x component, so dx over dy. Yeah, and we have to take a tan of it, right? So a tan of that. Yeah, but now only thing is whether that will be correct or not. Now what we can do in that case, is we can also use what is this may be incorrect because of we don't know which quadrant it is in, so to deal with this problem, what you can do, you can also use attend to. Yeah, so I think in MATLAB, okay, so attend to, yeah, and then you can give the y value and x value. Yeah, so that gives you a better picture, and we can have dx txy and then y value. So y value will be 1 2, and then you give comma dxy, and then you have 1 comma 1. Yeah, so you go like this. So this one, we will, the first one we are going to comment it, and we can go ahead with this one. So this gives you angle. We have defined ang as this, and we will save whatever color we made. We can save it. Remember, here we don't need to write this first and then substitute here. We could have just written the same thing here itself, and I would have saved L, basically. No need to put, but still I'm doing it right, as I said earlier, writing long way so that you understand what we are doing. And here same thing we'll do, ang and 1 I. So I'm saving it now. So this we calculated, this we are saving it in the global matrix, which will be remaining. This will be gone once it is out of this value, this loop. Okay, this may not be relaxed, but so ang 1 I is equal to angle. Yeah, that's it. So that way angle is saved. Okay, so now we can also uh, run it and see whether, so let's see. 24. Okay, somewhere NE is written over here. Okay, so it gave me error because see, this is case sensitive. Okay, so yeah, so it has worked. Now you can see the angle. We can find out ang value, and what you get here is it showed you the value of giving you minus this. So that is fine. Yeah, so minus because see, the way we are calculating angle right now, it is coming from top to bottom. So all of them have negative values actually. Yeah, so all of them has, so first has minus. You can also calculate like ang multiplied by number of degrees if you want to calculate, because this gives you in radian. This, the answer is in radian. So angle multiplied by 180 divided by pi. Yeah, so I think pi will be, let me see. Yeah, so what you see is minus 45 minus 90 or minus 135, and which is correct. If you see, if you remember the problem, the first is oriented. So now your angle is from the top to bottom, okay, from node 1 to 2, 1 to 4, node 2 to 4, node 3 to 4. So our orientation is now different, so if you see the negative 145 degrees, the first one, second one is negative 90 degree, third one is negative 135 degrees. So it's fine. Okay. Any question, guys, so far? You are getting it, guys?
Yes, sir.
Yeah. Okay. Okay. So far we got the angles and the length. Now next we have to do the stiffness matrix, and we have the K. Yeah. So Kj, we write just K. Yeah. And that stiffness matrix is what? We have K is equal to, now we know from E, we know E, then A. Now area we have in terms A is given, so we can write A, and jth one, so is fine, divided by L, length. We have the length LE, we wrote LE, so LE again, the jth one. Okay, so EA over LE multiplied by, yeah, and after that we can use all cos theta, sin theta type things that you did. Either you can do that, or you can also use rotational matrix based. That's also possible. So what we will do here is, there are three types, right? One we call it C. So C is a cos square. So cos and angle, ang, j. Yeah. So cos ang j, and we made a square of it, and s we are writing is equal to, so we are writing shortcut so that we can easily write. So while programming, these are the things, tricks, small tricks. If you are a regular programmer, you would know that this is how we do typically, so we don't want to repeat big things. We make it, we assign it to a small correct value, and from there we go ahead, so it's like this one. Yeah. So CS, and then we can have CS like this, or some other thing also. This is a product of that, so we can also write P, P equal to product of sine and cosine. So we can have cos multiplied by sine. Of course, a square term we have to remove. So here you go, and here like this. So cos times sine, all are jth one only. So now it's become very easy now. Yeah, and then see what we can do. We know that 4 by 4 matrix, and they are like cos, sine, cos, product, right? Minus cos, minus product, right? And then you have, similarly you can write, yeah, and then you have product, Then you have product, then you have sign, then you have minus, product minus sign, done. Okay, now after that, so whatever here will be, should be here, and so on. Now if you look at here, then you will get the third one should start like this. So this third one should be minus c actually. So minus c minus cos. Okay, and then what should be there? So this is like this. Okay, so okay guys, I think you can write here also. Just a minute. If you have difficulties looking at that, we can also write this way, so that we can arrange nicely like this. Yeah, so now we have minus c here, and then we will have minus p here, then so cp minus c minus p s minus p minus s. Now you have the p s here, so you get minus p or minus s here. Yeah, okay, then you get c, you get p here, then you get p, then s here. Okay, same thing I will write actually. So this is how this will be, and we'll remove this one because I copied from there. So all these things is nothing new. Basically, this all you have done. I'm just putting it into the program now. That's it. Okay. So here we are like this. Okay. So call it KE element. So that we have made. Now what we have to do is assemble into in the big one, K. Yeah. But in order to do that, we have to identify what is the corresponding degree of freedom. Right. So DOF, we have to find out DOFE of the element. Yeah. And what is that? That is for that element, we have nodes. Yeah. So we have the node number 1, node number 2, and so on, right? So uh, so corresponding nodes we have to find out so that we can prepare the degree of freedom. Yeah. Okay, so for number 1, for example, is connected to number 1 and 2, so degree of freedom will be 1. So okay, so first we find out the nodes, which all nodes are there. So uh, this one, the same thing, these guys gives you the nodes basically, right? This one gives you the which all nodes are there. This is node number 1, and this gives you node number 2, right? Same thing I will copy it here. In programming it's not a good idea to copy, remember that. So you program such a way that you don't write the same code again and again, but still I'm doing it because here anyway the idea is to have the very basic programming. Yeah, and you can improve on your own. So this tells us which all nodes are there. So degree of freedom will be equal to, will be, so first node is n1, second node is n2. This is node number. So that means what? N1 multiplied by 2 minus 1 is the first degree of freedom. N1 multiplied by 2, sorry, second degree of freedom will be this. So if n1 is equal to 1, then what happens? 1 times 2 is 2, minus 1 is 1, right? So this becomes 1. Then n1 is 1, multiplied by 2 is 2. So it becomes 1 and 2 here. Similarly, for same thing, you can write it here. So n2 multiplied by 2 minus 1, n2 multiplied by 2. Okay, whenever you program, remember that sometimes you copy and you forget to change things, So although I copied, same thing here, but the idea was to change from n1 to n2. So I did that. So this gives you the what is the corresponding degree of freedom for that element. Yeah. So for every time it goes through this loop, this will recalculate degree of freedom. Yeah. And once we have that, we can assemble it. And how do we assemble? We simply say k. Yeah. So k, this is the big K, is equal to, we'll do it just a minute. So k here, and which one? Degree of freedom E, DOFE. Why? Because we want to just add in this degree of freedom only. We are replacing there is equal to whatever the existing one we want to add on top of that, right? So if existing, whatever existing is that, on top of that we are adding what? Adding k. Which k? This k, ke, and done. You would say that, you know in on paper, when you have to assemble it, how much time you have to spend. Here you see, you just write this one line and it's assembled. So this is the assembly of stiffness matrix, and you run it. Yeah, so we can run it now. We'll see whether we get assemble it or not. Yeah, it's done. Now put big K now. See, we got this big K value. I think this side, if you see. No. Okay, hold on. I think this I can push it up. Yeah. So this is the K value. Just a minute. See, this is the stiffness matrix. Something is wrong. I think. How come it's a zero coming? 1, 2, 3, 4. It has added just once. So let me see what happening. So J number of elements. Okay, so
Ni equals to I that you copied their problems. You have to replace with J. Line number 30.
oh yeah. See? Oh man. So that's why you have to be careful, guys, Right. Yes. Yeah. So very a small problem, you end up in errors. So remember. ठीक है. Thanks, man. Thank you. Yeah. Yeah. Now let us see. Yeah. Now it's good. Thank you, man. So you see now, it has actually we got this now. Yeah. So this is the K, assembled K now. Yeah. And once you have that, there is nothing much left now. So rest you can solve it easily. And how you solve it? We will go. So we have the K matrix. Now we have to define degree of freedom. So we have to write fixed degree of freedom. Yeah. Okay. Or EDV. Okay. Fixed degree of freedom is which one? We can write, actually we know that fixed one is degree of freedom 1, 2, 3, 4. 5 is free. Number 6 is also fixed. Yeah. Fixed degree of freedom is this. And which degree of freedom is free? So free degree of freedom is equal to, we know that we have 5, 7, and 8. So these 5, 7, 8 are the free degree of freedom that we know. And how uh, we can solve the problem as like this. So you can find out the u free, where the free degree of freedom that we have to find out. uh, okay, so I think f free is equal to, we have a number 1 and number 5, we don't have anything, so we have 0. Number 7, we have 1e3 force, and there is no force in upwards, so we have 0. Yeah. So like that. But remember, we have to make it a vector, so transpose of that we made. Yeah. And we want to find out u free. What we do is k inverse of that multiplied by f free. But k which one? K only free degree of freedom only we have to take. Yeah. So k free degree of freedom, and do like this. So this saying means u equal to k inverse f. This is the meaning of k inverse f. Okay. Okay. So, and you will get the answer. U free you will get. So let's do it. So column 24. Yeah. So it took some time to do it, and you write u free. You got the value. See, this is the value you got as the displacements. Yeah. 1 times 10 to the power minus 5, and these two value. This one is for degree of freedom 5. This is for 7. This is for 8. You got that? Yeah. So this is how you do, guys. Whatever we did yesterday, we did it today. So we did the programming. Also MATLAB I used after a very long time. Actually, I installed it just today. I did not know that IT Roper association I mean, the email will let me do it. I don't know whether it will be applicable to you all guys also, but I could install from MATLAB website. Maybe we are subscribing to them. Also, you can do online as well. They have on their website, you can access online. So details about this you may actually find out from our IT section, so whether we subscribe to and what kind of license the students of IT doctor can get. So all those things please do on your own. Yeah. So but only I can tell that I'm using a license, authentic license basically, and which I got it downloaded just today. In fact, I started at 9 o'clock. I am able to install it. And this is what you are saying it. Any question, guys? Anything? Okay, guys. So if there's no question, then we will continue on this tomorrow. So we have to also find out the stresses and all. So that we will do it tomorrow. Okay. I will also share with you this file with you guys. Okay. So you can also look at this. Okay. Okay, guys. See you tomorrow.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.